Hi, in this video, I want to go through installing Kaito version 0.3.1 on Azure Kubernetes Service to host a large language model. So what is the Kaito operator? Kaito stands for Kubernetes AI Toolchain Operator, which automates the AI ML inference model deployment in a Kubernetes cluster. So what this does is that it can take these supported models listed here, finding this URL. So for now, at this moment of this recording, you have Falcon, Llama 2, Llama 2 Chat, Mistral, Phi 2, and 3. And you can deploy those large language models onto a Kubernetes node pool with a defined VM with a virtual machine SKU with a GPU, especially an NVIDIA GPU. So, what are these large language models? They come in with different capabilities and sizes and parameters. And so you can check them out at a Hugging Face website. But these are just a summary of what they are. And in a future video, I can go through them in more detail. Once Kato is set up, you can kickstart deployment of one of those LLMs, right, and with onto a user node pool with a particular VM SKU or instance type. So what we have here is a YAML file we call a model preset of a kind of workspace. It's a custom resource in Kubernetes, and we define the instance type and the actual model, right? And then to initiate that, we can do kubectl apply. And as Kato is installed and set up, it will go through its process of automating a model into your Kubernetes cluster. So if you didn't have Kato, then one would have to develop a bunch of scripts to automate the multi-step process, which entail creating that node pool with a given VM SKU with GPU. Your Kubernetes cluster has to have role access, the right kind of identities to create the node pool resources, and then figure out how to deploy an open source LLM onto that node pool as a deployment or a stateful set, and so with varying set of configuration properties. And then again, you would need another script to deprovision deployed costs. So it's really a bunch of serious steps, but what Kato provides is streamlining that process such that all you need is this model preset YAML, and Kato will provision that for you. Here I'm going to go through the key steps, right, just to break it down to make it easy to understand. So step one, let's start off with your standard vanilla Kubernetes cluster. No special, very default settings. So we have a Kubernetes cluster, a system node pool. So this obviously does not have any GPUs. It's just to run your standard nodes, quality monitoring agents or software agents, etc. And of course, running itself. So the first, after you create the Kubernetes cluster, you do the first step is to deploy your workspace controller. So this workspace controller is custom to, and what's with this kind of Helm install is that it deploys a bunch of CRDs. I just listed two of them. So it's a custom resource definition. And a custom resource is an extension of the Kubernetes API that doesn't really come default to a Kubernetes installation, right? So these CRDs are just basically, they're not running services, they're just definitions, right? And really, it's just definitions stored in the etc database. So from the creating an instance, an actual resource from the workspace's CRD, you have this workspace controller. What it does is that it reconciles the workspace custom resource, and this controller is basically a control loop that watches the state of your cluster then makes requests or changes where needed, right? So this workspace controller will watch for the model preset YAML I just showed you. The workspace controller also creates a Carpenter machine resource, which triggers the GPU provisioning. And then it creates the inference or tuning workload based on the model preset configuration. So the next step we have here is to enable these feature flags on the Kubernetes resource itself, enable OIDC issuer and workload identity. So workload identity allows pods to authenticate against Azure resources without using secrets or credentials stored in the cluster, right? So OIDC is an authentication layer built on top of OAuth 2.0 protocol, enabling workloads within Kubernetes to authenticate with external identity providers using standard tokens like JSON web tokens. So the OIDC issuer allows Kubernetes pose an identity token endpoint that external systems like Azure Intra ID can trust for validating the service tokens. So when a Kubernetes service account and pod are configured to use the workload identity is injected into the pod runtime. And workloads using this account can issue tokens that can be validated via the OIDC issuer. So next, what we want to have is the managed identity. So I called it Kaito provisioner, and give it a role assignment of role contributor onto the scope of the Kubernetes service. We have deploy the GPU provisioner. So it's another Helm chart. And this provisioner is a controller, the machine.carpenter CRD, originated from the Carpenter open source project. And it interacts with the workspace controller. So it needs to integrate with Azure and have the permissions to be able to create a node pool with the specified VM SKU. To bridge that, we need on the managed identity, there's a setting called federated credential that we can create. And let's call that Kaito federated credential. So a federated identity credential creates a trust relationship between an external identity provider and a managed identity in Microsoft Intra ID, which is this one right here, this managed identity. So in this case, the GPU provisioner controller is the workload that has Azure Intra ID permissions to be able to create that node pool resource. So we have this GPU provisioner controller leveraging the service account, and this basically, in order to create the node pool, it needs Azure permissions to those resources. So with the combination of these enable OIDC issuer and workload identity, managed identity, having that role assignment, and a federated credential, which refers to the service account, and working with Azure AD, it is able to create that GPU node pool. So at this point, Kaito is pretty much set up. And so the next step is to refer to a model preset that I showed a couple slides ago, run that YAML. And by running that YAML, what happens is that workspace controller orchestrates that process, which calls into the GPU provisioner controller, which of course now has that permission to do so, creates the node pool resource size to have that includes those GPUs. As you see here, the NC12SV3. Maybe 10 minutes later, after this GPU node pool is created, will then retrieve the LLM in a container image. It can either be in a public registry or your own private registry, and deploy that default namespace or any namespace. And in this case, it is deployed as a Kubernetes deployment. Once that is up and running, the next step in my demo, which I'll show, is to test it against this HTTP, this API. What I do is I deploy a simple curl pod and just call upon the HTTP endpoint and pass it the prompt and various parameters. and that will return the completion, the prompt completion. Next, I will turn to show all these steps in action. So I'm going to go through deployment steps in a demo. But before we do, of course, you can find the steps that I used here in the project repo, right? So first of all, you want to start off with AZ login. These are my variables right here, defining the resource group, cluster, the region, etc. Okay, I already ran this. The first step here is to create the cluster, vanilla default. The only thing I want to change, I just want to make the node count 1. That's to save on my costs, right? As much as I can. It runs fine for these demo purposes. So let me just run this in variables. Again, first off, what we want to do is create the Kubernetes cluster. It's very default, very vanilla. The only thing I change is the default's node count 3, but I just wanted to make it 1. That's just to save on, so go ahead and run that. A few minutes. Pause the video. The Kubernetes cluster has finished. Let me turn over to the a good refresh. I named it AKS Dev 3. These are my other demos right here. You can see it succeeded. It's running. Look here. Our standard thing to look at is custom resources. These three will have some custom resources shortly. And note that the node pool is we only have one running node pool. We have only one running node pool. This cluster has been created. I'll go straight into into that cluster. There we go. Therefore, can go kubectl get nodes. That and go ahead and install the workspace controller. Deployed. Turn over to the cluster. So here we'll see a whole bunch of custom resources. There's custom for workspace, spaces, workspace right here, workloads. Use the Kaito workspace, and we have a right here, right? So that's the Kubernetes controller. Now, to enable these features, the AKS resource. So that has next is create an identity, a managed identity, and assign it permissions. So it's here. Let's the option for my demo, and then let's create that identity, the principal ID, and then we get the ID. And then now what we can do is create the role assignment, okay? Allowing that managed identity to have contributor role onto that AKS cluster. Great. What we do is create the federated credential, the managed identity. So, okay, before I do that, we can look at Azure portal and go find there we go. That's the role assignment. Next we'll create the federated credential. So first we need the OIDC issuer URL. It is right here, and what I do is have the issuer. So I will create a service account, right, for the GPU provisioner, this cluster, but we'll if we refresh that, like there you go, we see that there. Object identifier. Okay, so pay attention to this detail. Service account. And the next step. So what we're going to do here is the GPU provisioner deployed. If we do kubectl describe sa GPU provisioner, we see versus right here. So to this cluster, see loads and GPU provisioner namespace, and there that if you look at the YAML, let's look for service. So we have here details of the service account, GPU provisioner, whoops, service account name. So that is that reiterated. Oh, and resource settings there. I just have a bunch of variables that I can kind of select. So, but we're after the Falcon 7B. Variable, and so here Kaito's been set up. Now we want to use operator and this okay, and see, we can look at the inference model. One Falcon. So that's once again the preset YAML. Okay, use this one. Okay, save. I'm gonna run that. This controller will again orchestrate the creation of this and working with that GPU provisioner controller to create that second node pool. And this will take quite a bit of time. So watch its progress. There's this command kubectl get workspace watch. We see here the instance. We want to see values, resource ready inference space succeeded to be true. Okay. Back to the Kubernetes cluster, we go to node pools. You hear that second user node pool, NVIDIA GPUs, is being provisioned. So that's going to take time. So I'm going to pause the recording where we can see the progress as it's kind of deployment. So the resource is ready. However, the workspace is not. So give it a few more minutes. So let me pause again. So now we're back and we have it all set up now. True. Here, so see. So the Azure portal. Go back to the node pools. Now we're at the node pools, and we can see right here the user GPU got provisioned. We see that their node size is using the NC12S v3, which is NVIDIA GPU. And if we go to the workloads, see that default namespace, we have the Falcon 7B provisioned. We can do a prompt into that. First of all, the LM is exposed as a service, and so let's get the cluster IP. Okay. Now, okay. So some prompts I have. So let's say how to create a virtual network in Azure. We want to run a pod with making a curl command, executing this curl command post against the endpoint, LLM. And so we give some headers of type JSON and the as having the AI prompt and some other parameters. Okay, so let's run that. Well, it took some time, but as you can see that we have the result here. And how to create a virtual network in Azure. In this article, explain on etc. Reading through this, it's not too bad. Okay. Came up with some, let's say, Azure CLI code. It just gives you by step as to how accurate this is. Just reading it, you can evaluate for LLM hosted in Azure in our AKS cluster, and we can prompt it. So anyways, thanks for watching this demo. Hope you find you like it. Appreciate the subscribe and like and a comment. I will do some more. Thank you.